press the bell icon on the YouTube app and never miss another update.
Yeah, hello dear students. Now let me continue system of particles and rotatory motion in that center of mass part 5. Okay. So in this part 5 again I am going to solve some more numericals, okay, which are helpful for all type of exams. So let me solve one problem I written already on the board. See, if the center of mass of 1 kg, 2 kg, 3 kg is at 2, 2, 2. Center of mass of 1, 2, 3 kg is given 2, 2, 2. Then where should a fourth particle whose mass is given 4 kg placed so that combined center of mass may be at origin, may be at 0, 0, 0. So read the question. If the center of mass of 1 kg, 2 kg, 3 kg given at 2, 2, 2. 1, 2, 3 kg given, center of mass is 2, 2, 2. Now at what place we have to place the 4 kg mass so that combined center of mass may be at origin. So we need to find coordinates of fourth particle. Coordinates of fourth particle. When 3 particles are there, the center of mass is given 2, 2, 2. Now at what distance 4 kg should be placed so that center of mass will comes to the origin. Center of mass will comes to the origin. So let us see this one. See, first these 3 kgs, 3 particles are at 2, 2, 2. So let me solve only one coordinate now, Xcm. Xcm is m1 x1, m2 x2, m3 x3 by m1 plus m2 plus m3. For 3 particles, center of mass is given 2, 2, 2. So this let me take 2. Xcm is 2, Ycm is 2, Zcm also 2. Let me find only Xcm now. M1 1 kg, 1 x1, M2 2 kg, 2 x2, M3 3 kg, 3 x3 by 1 plus 2 plus 3, 6. So I got one equation, x1 plus 2x2 plus 3x3, which is equal to how much? 12. Keep this as one equation. Okay, when x1, x2, x3 for 3 particles, the center of mass is at 2, 2, 2. So I use this up to here only. Then where should 4 kg will be placed so that center of mass will shift to the origin? If I use m4 x4, then Xcm must be 0. Okay, this is for 3 particles. If I use the fourth particle, say for fourth particle, we can write Xcm dash is m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 by m1 plus m2 m3 m4. Okay. And what is this Xcm dash? The new center of mass is what? 0. This is Xcm dash, Ycm dash, Zcm dash. So this is 0. Okay. And this is 1 plus 2 plus 3 plus 4. M1 x1, 1 into x1, 2 into x2, 3 into x3, 4 into x4. Anyhow, this is 0. Okay. Now I got x1, 2x2, 3x3, 4x4, which is equivalent to how much? 0. But from equation 1, x1 plus 2x2 plus 3x3 is equal to 12. Substitute in place of this, just you take 12 plus 4x4 is equal to 0. Now 4x4 is equals to minus 12. What is x4? Minus 3. x4 is I got minus 3. So, fourth particle we have to place at a minus 4, okay, minus 4 coordinate. If it is a centimeter, centimeter, meter means meter. In the same way, if you solve for Vcm, you will get the same equation. ZCM, you will get the same equation. So, similarly, we can write y4 coordinate is also minus 3, z4 also minus 3. Don't say. Yeah. Now, fourth particle we have to place at minus 3 comma minus 3 comma minus 3, then center of mass will be at origin. So, initially center of mass is given 2, 2, 2. If 4 kg will be placed, if this 4 kg is placed at a coordinates of minus 3 comma minus 3 comma minus 3, then center of mass will comes to the origin. So, this is also somewhat good question. So, take this, okay, follow this method to solve some other questions. Yeah, here 4 kg will be placed at a coordinates of minus 3, minus 3, minus 3. Then center of mass of that combined system will comes to the origin. Okay, let me rub this now. Okay, next let me try one more good question. Sure, let me write the question. Write the question along with me. So, a particle or a projectile. So, a projectile is fired into the air with a speed of 100 meter per second by making an angle 37 degrees with the horizontal, 37 degrees with the horizontal. The given at the highest point, the projectile breaks into 1:3 ratio. And the smaller part comes to rest. The smaller part comes to rest. Then at what distance the heavier part will land? The heavier part land from initial position. So, this is a somewhat good question. So, take this question first. A projectile is fired into the air with a speed of 100 meter per second by making an angle 37 degrees with the horizontal. At the highest point, the projectile breaks into 1:3 ratio. Okay, if mass is m, that mass will be split up into 1:3 ratio. If total mass is 4m, one is m, other one is 3 times of m. So that will be split up into 1:3 ratio. The smaller part will comes to rest after the explosion, and then where the second part will land, means at what distance the heavier part land from initial position. Read question twice. Okay, first imagine the diagram. I think you are good in projectile motion. I think you remember the range of a projectile, maximum height of a projectile and all those things. Okay, let me use here some range formula based on the situation here. Here a projectile fires into the air like this. Okay, 1:3 ratio means total mass is 4m. Okay, and this is makes an angle 37 degrees with the horizontal, and at the highest point, when it reaches at the highest point, this total mass, okay, total is 4m, 1:3 means 4m. One particle immediately falls at the highest point, immediately comes to rest, and next particle, see, this is the 4m original mass. After the explosion, you know that center of mass will follow the same path, like a parabolic path. Okay, from here to here is center of mass. Is it visible downside? So m will land here, and this is what? Xcm. And see, second particle will land somewhere. See, the second particle maybe here. Here 3m will land. Now the target is to find at what distance second particle will land. Okay. So this is first particle. If m1 is m, and this is second particle whose mass is m2 is 3m. First particle having a coordinate, let me take x1, second particle coordinate is x2. Downside everything is visible. Xcm, x2 is okay. Yeah. So coordinate of m1 is x1, coordinate of m2 is x2. Target is to find x2 value. See, this is the diagram. Find x2 value. And Xcm is very clear. What is Xcm? Xcm, which is equivalent to range. So from here to here is range, original center of mass. So Xcm nothing but range. Xcm, which is equivalent to range, which is equivalent to m1 x1. Okay, Xcm is range. From here to here is Xcm nothing but range. So what is this value? Range formula, you know, u square sine 2 theta by what? G. I think remember the formula. This Xcm, which is equivalent to range of the projectile. So what is the range formula? U square sine 2 theta by G. U square sine 2 theta. What is U? 100. Okay, 100 square sine 2 theta. 2 sine theta cos theta by G. Let us take 10. G you can take 10. And here, let me rub the question. Okay, I am going to rub the question now so that I can use the space properly. So what is range? So Xcm is equals to range. So we can write u square sine 2 theta by G. So this can be written as u square 2 sine theta cos theta by G. What is u? 100 square 2 sine 37 I think you remember sin 37 and cos 37 by g as 10. So recall some 37 triangle. Okay, so use this triangle system to get 37, 53 and all the values. So keep this triangle in mind. 3, 4, 5 triangle, this is 3, 4, 5, keep in mind. If this is 37, no doubt this is 53. So we can get sin 37, cos 37, tan 37, cot, cosec, all 37 values. And if this is 53, we can get 37, 53. This is 90. Okay, total value is equivalent to 180. So we can get sin 53, cos 53, tan, cot, all 53 values. So remember this triangle. Sin 37 from this triangle is 3 by 5. Cos 37, 4 by 5. So this is 100 into 100 to sin 37. Sin 37 is 3 by 5. Cos 37, 4 by 5 all divided by 10. So 0 gets cancelled. Okay, so you will get 5 2s are 5 20s are 2 2 4 80 3 24 and 24 and you check it is 980 meter. Check this value 980 meter. 24 4 4 the 60 will come, no? So 960 meter. Check this calculations. So I got range nothing but Xcm. How much I got now? Xcm. Center of mass of this system is 960 meter. But our target is to find at what distance the heavier part will land from the origin. Up to here is 960 meter. Up to here is 960 meter. But see, second part will travel some more distance. So you find this one. Otherwise you find directly x2. By using center of mass, let me find like this. Xcm is equals to m1 x1 m2 x2 by m1 plus m2. What is Xcm? Xcm is very clear, 960. Xcm is nothing but range. That is 960. m1 is m. x1 is half of range. X1 is half of range. From here to here is range. This is half of range. So half of range. X1 is nothing but half of this range r by 2. M2 3m. X2 is our target. M plus m. This is 4m. So 960. All m's gets cancelled. Take this 4 left, 960 into 4, r by 2, range by 2, 960 by 2, 960 by 2 is 480 plus 3x2. Solve x2 value. So 960 into 4, 960 into 4 minus 480 is equals to 3x2. So take 480 common. This is 8 minus 1, 3x2. Okay. 480 you take common. This is 2. 2 into 4, 8. 8 minus 1, 7. So 480 into 7, 3x2. 3 1s are, 3 6s are, 0s are. 16, 7. So 16 7s are 1120 meter. Check the calculations. So second part will land at a distance of 1120 meter from the initial point. From this center of mass, just you take this one. 1120 minus 960 will give this value. 1120 minus 960. So I got 1120. So second part will land at a distance of 1120 meter from initial position. Okay. See, here a particle projected into the air, nothing but a projectile motion. Projectile fired into the air by making an angle 37 degrees with the horizontal, and that is fired with a speed of 100 meter per second. and due to some internal forces it will be explodes at the highest point. When it explodes at the highest point, the smaller part will land at the same place, but the heavier part will land somewhere. But center of mass will follow the original parabolic path, how that earlier it follows. So, center of mass will follow the original path, and this is the position of center of mass of this projectile motion, and this nothing but range, xcm nothing but range of the projectile, and m1 is at a half of range, nothing but x1 nothing but r by 2, m2 at a distance of x2, target is to find out x2 value, means where the second particle will land from initial position. Then I calculated here range, okay, range nothing but xcm, so I got 960 meter, and I use a regular formula like xcm is equal to m1 x1 plus m2 x2 by m1 plus m2. What is x1? x1 is half of range, x2 is our target. So, finally, I got 1120 meter. So, the second particle land at a distance of 1120 meter from the initial position, from the point of projection. So, slowly the question levels are increasing, try to practice number of times, okay. Now, let me give one more easy question. So, I am going to cover different models here, try to use these knowledge to solve problems from any other level of books. Next, I am going to cover some concepts also based on center of mass. Still concepts are not yet started, okay, next class maybe concepts are going to start. Those concepts will help for all type of entrances, okay. Right now, I am solving some easy level of problems to get some confidence about system of particles and rotatory motion, because students feel generally tough this chapter. So, let me avoid that toughness, that is why I am following very easy way and I am solving easy level of questions. Now, so try this problem. Find velocity of center of mass as shown. So, they given like this. So, this is also easy level of questions. Something m naught moves with a speed v naught, and one more m naught moves with a speed again v naught by making something 37 degrees. One more m naught moving back with 2 v naught. Yeah. Find velocity of center of mass, Vcm bar, vector symbol. Okay, they may ask to find RCM bar by giving R1 bar, R2 bar. R1 bar is in vector form like xi cap plus yj cap. Here 3 particles they given whose masses are given m naught, m naught, m naught, all are same. Take this is yeah, no problem, you can take all are same. If they given different, you can take different. But first particle is moving along x axis right side, second particle is moving in xy plane, third one is moving left side. First identify in what direction the particles are moving, because velocity is a vector. So, identify the velocity in terms of vectors. First particle of mass is m naught. So, m1 is m naught and this is moving along x axis. So, v1 we can write it as V naught I cap, because it is moving right side, V naught I cap. And here this particle moving by making some 37 degrees. Take this is M2. So this particle is moving by making an angle of 37 degrees along the x axis. Sorry, 37 degrees with respect to the x axis. So M2 is M naught, but this V2 we can resolve into two components. V naught along x axis, V naught cos 37. Resolve this V naught into two components. This is what? V naught cos 37. And what is this? V naught sin 37. V naught cos 37, V naught sin 37. This is along x axis. So V naught cos 37 I cap plus V naught sin 37 j cap. If it moves in this direction, you can resolve. One is negative y axis, other one is negative x axis. And coming to the M3, M naught and V3, it is moving left, minus 2 V naught I cap. Why I am using minus? Because the particle is moving left side, so negative x axis. So I got M1 V1, M2 V2, M3 V3, then Vcm. What is Vcm formula? Recall once. Vcm. M1 V1 bar plus M2 V2 bar plus M3 V3 bar, so on. Okay, but three particles. So Vcm bar is M1 V1 bar, M2 V2 bar, M3 V3 bar by M1 plus M2 plus M3. So substitute the values, you will get answer in terms of vectors. If they ask you to find magnitude, you can take the root, because you know vector rules. What is M1? It is M naught. V1, V naught I cap. M2, it is also M naught. V2, V2 is V naught cos 37 I cap. Okay, let me multiply this. Okay, V naught cos 37. Recall cos 37 value. Use the triangle system again. This is what? 37, 3, 4, 5 triangle. So V naught cos 37. Cos 37 is 4 by 5. V naught, sorry, 4 by 5, and I cap is there, no? I cap plus V naught sin 37, 3 by 5 j cap plus M3. What is M3? M3 is M naught, but it is moving left, so negative sign. Okay, minus. So V3 is minus 2 V naught I cap. Okay, let me write minus here. 2 V naught I cap. It visible right side part. Yeah. Substitute the values. Okay. This is M naught, M naught, M naught, 3 M naught. Simplify the values. Add I with I, J with J, K with K, because you know vector rules. So Vcm bar is M naught everywhere gets cancelled, so there is no need to worry about M naught. V naught I cap 4 by 5 V naught I cap 3 by 5 V naught J cap minus 2 V naught I cap by 3. So Vcm bar V naught I cap 4 by 5 V naught I cap 2 V naught I cap. So this is 5 V naught. Okay, do the LCM. 5 V naught I cap 5 V naught plus 4 V naught, 5 to the 10 V naught whole divided by 5 into I cap do some simplification, use some basic mathematical knowledge, and 3 by 5 V naught j cap by 3. Okay, 5, this is 9 minus 10, so minus V naught by 5 I cap. Okay, so 9 minus 10 minus V naught I cap by 5 plus 3 V naught j cap by 5. 5 you take downside, so minus V naught, if you take V naught outside, minus I cap plus 3 j cap by 10. Extend it. Extend this step, one more step, because of the space I am unable to write here, so you extend it. Yeah, extend it, got the answer. Then if they ask you to find the magnitude, you can go for root of I cap square plus j cap square, you will get the answer. You know how to find the magnitudes from vectors. Okay, you extend this step. Okay, let me write here. I think you extended most of them. So what is VCM bar? 5, 9, minus 1, minus 10, so minus V naught I cap by 5, 3 V naught j cap by 5 by 3. So VCM bar is, if you take V naught outside, minus I cap 3 j cap divided by 15. If they ask you to find the magnitude, so VCM bar, so V naught by 15, because square this 15 will come outside anyhow. So this is 1 square plus 9. So root 10 V naught by 15. If they ask you to find the magnitude, you try to extend up to the magnitude. Otherwise, you keep the answer in vector form. So based on the given option, you extend your calculations. Let me continue 2 more problems. Next I will continue concepts, means in the next class I will continue concepts. Find position vector of center of mass, position vector of center of mass of the system as shown, of the system as shown. I will give the diagram. You try to find the position vector of center of mass, nothing but RCM bar. RCM bar nothing but XCM I cap plus YCM j cap. So the given like this. Here one particle whose mass is m naught, This is something at a distance d. One more is mass also m naught, some 3 times of d. This is also m naught at a distance of t. Yeah, they given this diagram. Find position vector of center of mass as shown in figure. 3 particles they placed from origin. First particle is at a distance of d from origin. Second particle is at a distance of 3d from origin. Third one is also given. Identify the coordinates first again. Same thing. See, for first particle only x coordinate is possible. Second particle also x coordinate is possible. But for third particle there are 2 coordinates, x coordinate and y coordinate. So the coordinate of this one is b comma 0 because it is along x axis. Coordinates of this one is 3d comma 0 because this is also along x axis. Coming to the third particle is at a distance of 3d from origin and at a height of d. So coordinates are very clear, 3d comma d. Then find Xcm, Ycm and Rcm. Find Xcm. Xcm nothing but m1 x1 plus m2 x2 plus m3 x3. Plenty of models I covered now. Easy levels only. Try to do it fast. Xcm and Ycm. Let me find Xcm. m1 x1, m0 d, m2 x2. M naught 3D, M3 X3, M naught 3D by M1 plus M2 plus M3, 3 M naught. So M naught gets cancelled, D 3D 3D, 6D 7D, so 7D by 3, 7D by 3. And find Ycm, M1 Y1 plus M2 Y2 plus M3 Y3, M1 Y1 0, M2 Y2 0. M3 Y3, M naught D by 3 M naught plus M naught plus M naught. So what is Y3? D by 3. So I got Ycm. So I got 2 coordinates, Xcm coordinate and Ycm coordinate. They are asking to find position of center of mass, position vector of center of mass. So Rcm bar, we can write Xcm bar I cap, Ycm bar J cap. What is Xcm? So Rcm bar nothing but 7d by 3 I cap d by 3 j cap. So this is the position vector of center of mass of the system for the given diagram. I got Rcm bar. If they ask you to find the magnitude, you can go for the magnitude by taking roots. So root of 7d by 3 whole square d by 3 whole square, you will get the answer. Okay. So try to understand the process, how I am getting coordinates and how I am substituting. That way you observe it. There are different, one is along x axis, one is y axis. Okay, they may give anything. This is the one of the example for this model. Okay, let me give one more question. See, they given one pyramidal problem. They given this diagram. they given like a pyramid shape. So they place one mass here and all are identical masses. Yeah. So just you feel like a okay, feel the exactly square. Here one mass, here one mass, here one mass, here one mass. One more mass is placed it here, like a pyramidal shape. You imagine like a pyramid shape. Okay, I think I am getting exact. Okay, feel that a pyramid. Almost I am getting. So all the sides are same. All the sides are same. Let us suppose this side is A. This is also A. All sides are same. Okay, don't feel this is more. Okay, 3-dimensional diagram, but on board the diagram is looks like this. So 3-dimensional diagram, imagine in a 3D way, all sides are same. Just join a wire here, join one more wire, one more wire, one more wire, add all the wires here, take identical wires, attach one mass. So you will get one pyramidal shape. Okay, now for this type of systems, let us find center of mass, y coordinate of center of mass. Find y coordinate of center of mass. Find y coordinate of center of mass of a pyramid as shown in figure. Find y coordinate of center of mass of a pyramid as shown in figure. Y coordinate of center of mass of a pyramid as shown in figure. All the sides are A. So little bit different questions are started now. Does it appears like a pyramid? Check it once. Yeah, mostly. Okay. So this is A, this is also A. Don't think this is a more. This is also A. Imagine in a 3D way. This A. Get the y coordinate of center of mass of this pyramidal system given. Pyramidal system. So here at the bottom there is a square plate. You feel that there is a square plate at the bottom. At the four corners some mass is there. Plate mass is negligible. So 4 point masses are placed at here. 4 masses, 4 identical masses are placed at the 4 corners of that square, and one more mass is placed at the top at a distance of A. Now target is to find out y coordinate of center of mass of this pyramidal object. How to get this means, see, very simple. Join all these 4 as a single mass. Take all these 4 particles as a single mass object, because all are equidistant from this particle. From this mass, all these 4 are equidistant. So because symmetry is there, so all these 4 you joined and combined as a single mass. So let me draw an equivalent diagram. Here one mass, and if I join all the 4 masses, I will get the total mass is 4m, and the height is same. How much the height? A. Now you will get y coordinate of center of mass. Okay, so join all these 4, combine as a single mass whose mass is 4m, and that 4m is at a distance of A from the top mass m. So m and 4m are separated by what distance? M and 4m are separated by a distance of A. Now you will get a y coordinate of center of mass. This is like a 2 particles are separated by some distance. Then we know how to find out center of mass of that system. Center of mass from this, center of mass from this. Okay, let me find distance of center of mass from M. From M, this I am finding now. So to find this, okay, let me get this. Just recall the first and second class topic. To find center of mass from this particle, opposite mass into distance by total mass. M2 d by m1 plus m2. So xm is m2. What is m2? 4m into distance a by m1 plus m2. m1 plus m2 is 5m. So what is the answer now? 4a by 5. 4a by 5 is the distance of center of mass from the top. Okay, if it is origin, then from O, distance of center of mass from O is how much? Distance of center of mass from O is 4a by 5. Distance of center of mass from O for this given diagram is 4a by 5, downside is a by 5, total 5a by 5, 5 cancelled, a. Okay, think in a 3-dimensional way. Okay, let me give one more 3-dimensional question, and next we will see some concepts in the next classes. Okay, now you check this one. Find x coordinate, y coordinate, z coordinate of a cube as shown in figure. Of a cube as shown in figure. They given a cube. At the cube, at each corner identical masses are placed. So they given the diagram like this. See. So draw this diagram, try to get the answer. So this is x, this is y, z, all are identical, m, total how many m's? 8, because m 8 corners, 1 2 3 4, 1 2 3 4, yeah, each side is given a, each side is given a. First identify the coordinates. Yeah, 8 coordinates you need to identify now. I think you know this thing also in your mathematics. Anyhow, this is a uniform object, because all masses are identical, we can expect answer directly. XCM at the midpoint, YCM at the midpoint, ZCM at the midpoint, all are half height, a by 2, a by 2, a by 2, answer completed already, a by 2, a by 2, a by 2. Or otherwise check it. First identify the coordinates. This is x axis, y axis, z axis. Let me write the coordinates. This is very clear, 0 0 0, so everyone will tell. So 0 0 0, okay, written. Coming to the inner square first, inner square, inside square, this is inner square. Okay, you can give A B C D something name, 0 0 0. Now coming to this inner square, this is along x axis, then a 0 0, along x axis coordinate is a comma 0 comma 0. Coming to this is in what? xy plane, xy plane. So what are the coordinates? A comma 0. Coming to this is along y axis, 0 a 0. So inner square is completed. Written the inner square. Coming to the front square, inside square completed coordinates. Now coming to the front side face. Yeah, coming to this particle is in yz plane. This is in yz plane, yz. So what are the coordinates? Yz plane means 0 a. This particle is in yz plane, 0 a. This is along z axis, along z means 0 0 0 comma 0 comma a. So write correctly. I am writing very small based on the space. 0 0 A. This one completed. Coming to this. This is in XZ plane. XZ. So XZ means XZ. A 0 A. XZ. This is XYZ plane. So XYZ. A. Yeah, see the coordinates. So written the coordinates. Okay. Now coming to the x-axis, only x-axis. Along x-axis, only this side, left and right. Along x-axis, there are 4 identical masses. Just you combine it along x-axis. 4 identical masses. Combine all these 4. Left side also 4 is there. 4 identical masses. And see the gap from this to this. Only one A. This to this also A. See, this to this A. Now the gap between these 4 is only A. Subtract these coordinates. A minus 0, A minus A, 0, A minus A, 0. A minus 0, A minus A, 0, 0 minus 0, 0. Just you check it, everything. This gap. Just you combine these 4 masses, Now what is the gap between these? A. So again the same process. If 2 masses are separated by certain distance, then we know how to find center of mass. And one more thing, these are identical, then where is the center of mass? Midpoint. Center of mass is midpoint because identical at the center. So otherwise from 4m if you want to find opposite mass, so Xcm is equals to opposite mass into distance by total mass. So how much now? A by 2. Similarly, join all the top 4 masses, bottom 4 masses, combined it. So similarly 4m, again what is Vcm? A by 2. Combine along front back is z axis, into the board, out of the board, is nothing but z axis. So I want to draw like into the board and out of the board. So let me draw directly ZCM. On board means the diagram looks like this again because I am drawing planar diagrams. So A by 2. Now what are the coordinates in this system? A by 2 because it is a uniform body and all masses are identical. So A by 2. First suppose if masses are changes, then you have to find. Means you take this one. Let me take all front side masses, make double or triple. Then you find it. Right now, if all are identical, A by 2. If masses are different, if front side masses are 2m, back side masses are m, then coordinates of center of mass will change. Let us see how that values are changes. So I think this one completed. Let me do the next in this one. Yeah, for the same problem, let me do same problem. Just you see. Here I am taking 2m, front all are double, front face, 2m, front, back side is same, 2m, downside, inside is m. Now come to the x-axis, along x coordinate, left side just you combine all these masses, 2m, how much? 2, 4 plus 1, 6m. Left side also 2m, 3 2mm, this is 3, 6. So combine this 6, 6. So along XCM, how much the mass? 6m. 6m. Again, what is XCM? XCM is again same A by 2. XCM is again A by 2. Coming to the YCM. YCM, just top masses. 1, 2, this is 2. So 4 plus 2, 6. Top is 6. Bottom also 6. Check it. 2, 3, 4, 6. Bottom also 6. So 6m, 6m. A. Then what is YCM? YCM is again A by 2. Coming to the Z. Front face, back side face. Out of the face, into the face. Front, back. Front face masses you combine it. Front face. So on board I am drawing like this only. Front face masses is, let me draw like this, 8m. 2m, 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 2m. Total how much? 8m. And back side, m, 4m. What is the gap? A. Front to back, A. Don't think this is a diagonal like this, because I drawn like this. So the diagrams are different. Okay. Front 8m, back 4m. Gap between them how much? A only. 3-dimensional diagram, A. Then find the ZCM. ZCM. Okay. If we find from 4m, from back side, from 4m, from back side, ZCM we can write it as ZCM is opposite mass 8m into distance by total mass. Total mass is 4m plus 8m, 12m. So mm, this is 2, this is 3. So how much the answer? 2a by 3 from backside face. 2a by 3 from backside face. Front face is a by 3. Center of mass from front face is a by 3. From backside face is what? 4 to the 4, yeah, 2a by 3. Okay. So these are the level of questions. See, slowly the level of questions are changing. Okay, try to increase your speed so that I can teach little more. 2a by 3 is ZCM. Now XCM is what? A by 2, YCM, A by 2, ZCM. From back face is what? From backside face is 2a by 3. From front face, A by 3. From front face means opposite mass. Take this as origin, 4m into A by 12. So A by 3. If you add A by 3 and 2a by 3, you will get A, front back. See, slowly the problems levels are changing now. So in the next sessions, I am going to start concepts. Some concepts are there. Boat and man concept. Okay. I think the same concepts are there in previous chapters. Rain and umbrella, boatman problem. Here also boatman concept is there. That also I will continue. And some shift in center of masses purely for entrances. Okay. Next to almost 2 to 3 sessions purely for NEET, JEE and all other entrances. Only concepts with a small problems. Okay. So thank you.